Alright, welcome back to part 2 on how to solve a linear programming question using Solver. In part 1 we went straight into Solver itself to explain how to use the software. But at the same time, we're also aware that some of you might not be too familiar on how to use Excel or how to formulate this whole chart that you see here. So what I'm going to do is I'm going to delete everything and then we're going to start from scratch and I'm going to show you how we're going to solve this question. Okay, to start off, variable, this is something that we want to input. So effectively units, so this what it's saying is we want to sell 1 unit of X, 1 unit of Y, and 1 unit of Z. This is saying that per sandwich, how many sandwich do you actually want to sell? So number of units sold. Okay, quite straightforward. Okay, so let us move to the objective. The objective is that we want to maximize the amount of money we have. So for every one sandwich X we sell, we actually make $17. So what we're going to do is effectively use multiplication, this multiply by this. So likewise, for Y, multiply by this, and for Z. So effectively what it's saying, if we sell 1 unit of X, we'll make 17. We sell 2 units, this is how much we'll make. 7 units, this is how much we'll make. So now that we have individual sandwich X, Y, and Z, how much we'll make, right? We actually need to know collectively how much money would we make in the shop. So this is, therefore we need to sum everything. All right, 1 unit of each sandwich, we make 44. If we sell 2 units of everything, we're going to make 88. So straightforward, okay? So let's set this all back to 1. Okay, so now let us move on to the constraint. So in short, it's saying that for every 1 sandwich X, we would require 4 units of cheese. And for every sandwich Y, we would require 3 units chicken. Oh my god, did I say cheese? Chicken, I mean, sorry, chicken. So, okay, for every 1 unit of Z, we would require 2 units of chicken. So now we just need to fill out this entire table to reference back here. And there is actually a very fast way to do this. It's actually called locking of cells. So we're going to drag this out. We're going to drag this to autofill. But before I do that, I do need to lock down cell number 9 because I want this cell to remain because this is our input, our variable that we are going to change. So I'm just going to drag this out like that. If I'm not too familiar with this locking cell, I might do another separate video on this, but if you do not understand how to do the locking, you can just do this reference the cell individually, okay? So it works as well. Yes, let us move on to coming back to the constraint. Every day we have only 28 units of chicken available. So in order to know how much chickens we need for the day, we actually need to sum up everything. So looking horizontally, if we make 1 unit of each sandwich, this is the amount of chicken we need, which is a total of 9 units of chicken. Okay, so if I change this, see it changes to 13 units of chicken. So let us do the same for the cheese and beans. And there you go. All right, so end of it, you can just give your chart a test, you know. So let's say we're gonna sell 2 and 3 and 4 of this. This is the amount of chicken, cheese, and beans we will need. As you can see, I like to put my equation this way, you know, where our constraints is actually right beside it. So you can, it's a very easy comparison. Based on this amount of X, Y, and Z we're making, we can already see that we do not have enough cheese because total amount cannot exceed our constraint. right? So maybe we have to reduce stuff like that. Okay, so like as you can see, there's a lot of ways we can do this. We can do 1, 3, 3, or we can do 1, 3, 4. You can see we still have an excess of ingredients 1, 3, 5. Then you can see if we do it at 1, 3, 5, we have maxed out our cheese. But you can see chicken and beans are still quite short. We're still not quite making as much money as we can. So this is where solver comes in. Solver effectively takes all this information, and then it runs it really, really quickly to give you like a trial and error of how much you need. Because let's be honest, like, if you're going to try this, try to find the value of this, it's going to take you very, very long, okay? So I'm just going to go through the whole solver part also, just to just so that it's easier, you don't have to go refer back to the other video, okay? So let us go through this. Our objective is this cell right here, because this is how much money we'll make, how many sandwich we sell, and then this is the amount of money we'll make per sandwich, and this is the total amount of money we make. So we do want to maximize this. We want to be rich. We want to have as much money as we can. So maximize problem. Okay. Oh, sorry. So we do want to maximize this. Variables, as we talked about, are right here. How many units of x, y, and z? So let's do this. Coming here, x, y, and z. So this is what they will change. And now constraints. Let me just delete everything. Now in the previous video, we actually referenced cell by cell. So actually there is a faster way you can do this, okay? And then let me show you. Cell reference, these 3 cells must be less than these 3 cells. So instead of individually adding 3 constraints into solver, you can actually do this. So these 3 cells less than these 3 cells, and then you can just add it into solver. We will run the solver, and then you'll see it's actually the same. It gives the same result. The reason, and then it goes back to why we put the sorry, it goes back to why we put this whole format, this whole table like this, is just to make life easier. Like, I'm a very lazy person, so whichever gets the job done the fastest. Okay. Same thing, we do want to add the variables as an integer, because we do not believe in selling half or 3/4 of a sandwich. Okay, so add this in. So these are our constraints. Simplex LP, make sure they are non-negative. Okay, if you don't check this, sometimes it might run in X, we might run it into a negative, like say sell -1 sandwich, which in real life is not quite possible. How can you sell a negative sandwich? Okay, so but I won't go too much into that. Let's press solve. Let's see what we have. So it goes, the optimized number of things we should sell is 2x, 5y, and 2z, which will give us a maximum profit of $127. You see, just now when we were playing with the equation, like I think we will got 126. You can go back to the video and take a look. We're going to have all sorts of value, but solver is going to maximize this value. So it'll be quite difficult for you to, okay, maybe I'll say it's impossible for you to change the numbers to get a higher value of 127. Okay, so this is just the way solver is. Remember, just now we're also talking about our constraints. So same thing for cheese, we are maxed out at 80 units, so this is good. Chicken, we have 1 unit to spare, and then beans, we have quite a bit of units to spare lah. So effectively, this is how to format the whole thing to get your equations like that. Okay, just to be clear, we are selling 2 units of X, 5 units of Y, and 2 units of Z, which will give us a maximized profit of $137, such that our constraints are all met, where the chicken does not exceed 28, our beans does not exceed 80, and our cheese does not exceed 80, and our beans does not exceed 68. Okay, so this is effectively how you solve the questions using solver. Okay, in the next video, we're going to talk about the sensitivity report. We're going to talk about reduced cost. We're going to talk about shadow price. We're going to talk about all this kind of stuff. Okay, so if you're interested in reading all this, because it does give you a lot more information about your problem at hand, which I think is good to know. So if you're keen on that, do join us for the next video.